Now, before we go on to discuss RFM, I think perhaps it's a good idea that we first have a quick glance at the single point forecasting model. And the reason for that is that RFM is more or less an extension of the single point forecasting model. In single point forecasting, we're mostly concerned with these three numbers per activity. These three numbers represent one particular period, report period, except the budget, which is the total duration of the activity. So you have the expenditure to date, which is the B, and you have the progress to date, which is C%. And to get to the cost at completion, what we believe the cost will be at the end of the project, we simply take the B and divide by the C, like this. Very simple. This can then be represented in the graph. We have the budget, the expenditure, the cost at completion, and the progress. So you see the B, the C, the C. This progress is given the suffix ML, which means it's the most likely progress. We'll come back to what this means later. But to come up to this cost at completion, we simply extend this line to completion. And we see here that the cost at completion for this activity is above the budget. So we're expecting a cost overrun here. But it's very, very uncertain. This is only the most likely progress. To get to the total cost at completion for the whole project, we add all the activities. It's a straightforward addition of numbers. As already mentioned, RFM is an extension of the single point forecasting technique, but as you shall see, a very, very important extension. This graph is identical to the one you just saw, but not the continuation. To start with, we may assume that the expenditure to date is fairly accurate, but what about the progress to date? History shows over and over again that this number is indeed very inaccurate. Numerous studies have shown that the real progress at any time, especially the first 3 quarters of a project's lifetime, has proven to be way below the assumed most likely progress, or indeed much higher than the most likely progress. To compensate for this, we introduce in RFM a maximum and a minimum progress, which will form the outer boundaries of the progress at this time. The real progress is thus assumed to be within the outer limit of this minimum progress and this maximum progress, with the ML as the most likely. In my experience and based on my statistics, the lower progress limit is, for the longest period of the project lifetime, further away from the most likely progress than the maximum progress. But to illustrate the point, I have made the assumption that the progress is equal-sided. Hence, if we illustrate the distribution by means of a so-called frequency distribution curve, we get an equal-sided or bell-shaped frequency distribution curve as shown. The frequency or number of hits start close to 0 at minimum progress, climbs to maximum at the most likely progress, and drops again close to 0 at the maximum progress. Now, to get to the cost at completion, we extend the progress points to the cost at completion as we did for the single point forecasting model, like this. But now to a very important observation. Notice that although the progress curve is normal or bell-shaped, the cost at completion curve becomes skewed, and mind you, skewed towards higher cost at completion. Look at this. Firstly, the most likely cost at completion is higher than the budget. It's higher than the budget, which would have been exactly the same as for the single point forecasting calculations. But the most important observation is that the chance of an even larger cost overrun is very likely, since the cost at completion frequency curve is skewed towards higher values. Take also into consideration the fact that project people tend to be very optimistic, which means that the minimum progress tend to be optimistic. It should actually have been further down. This again would have resulted in the skewness at cost at completion being even larger. So the chance of an even larger cost at completion is higher. Hopefully you now begin to see why RFM may discover potential cost overruns much earlier than single point forecasting techniques do. Next question is, how does RFM calculate or predict total cost at completion? First, RFM lines up all the activities as shown. You will notice that all the frequency curves are identical in the example. This is not what it will look like in reality, unless in the unlikely event that all activities in your project are in fact equal. The reason why I've made the activities identical in the example is for the benefit of the viewers who are not familiar with cost risk analysis. To illustrate the uniqueness of RFM, let's actually start by discussing how the single point forecasting method fits in. In the discussions of the RFM model, we saw that the single point forecasting value corresponded to the top of the frequency or distribution curves. Hence, in order to derive at the total predicted single point forecasting value, simply add all the numbers corresponding to the top of the frequency curve. So you take this number here, add this to get to the total, which is this. Now, this is very simple, very straightforward, no fuss, but very misleading. Now, to do this in RFM, we have to sort to a simulation technique, and the simulation technique applied in RFM is the Monte Carlo simulation technique or method. What the Monte Carlo simulation technique does is simply picking numbers at random, like throwing a dice, from each of the frequency curves, adding and sorting to come up with this simulated resultant curve. So this is a simulation of all the curves above. You may wonder why it's bell-shaped and why the top of the resultant curve is to the right of the individual frequency curves. Well, this is nature. Nothing strange about this at all. To understand this better, I suggest you look up the Monte Carlo simulation technique on the internet and also read about the phenomena called the central limit theorem. You do not have to study the Monte Carlo technique in detail to be able to use RFM to its fullest, but after a while you probably get curious and will do it anyway. I must admit that I found the Monte Carlo simulation technique a bit of a hassle to start with, but know this: Monte Carlo technique mirrors the reality much closer than single point forecasting techniques do, and that's the whole point. That's the whole point with RFM, because it's so important to understand why the peak of the resultant simulated curve is to the right of the individual peaks. I will give you this hint before you start reading pages and pages of Monte Carlo theory. The 50% position for each of the activity curves is located where the area under the curves are identical. So 50% of all the frequencies are on this side and 50% on this side. 50% of the frequencies are on this side and 50% on this side. Same with this curve, 50% of all the frequencies are here and 50% are here. That's why the peak corresponds with the P50s or 50-50 for each of the individual curves. This is reality. So what has 30 years of experience with RFM shown? It has shown that for the given report period, the forecasted most likely cost at completion is a higher number than the forecasted single point cost at completion. So this point is higher than this. And the reason is simply that most activities are skewed towards higher values. It's a higher risk of getting into a cost overrun than the opposite. At 70% completion, that's 14 months of a 20-month project approximately, RFM often predicts a cost at completion more than 40% higher. So this point here is 40% higher than the single point. No wonder then cost overruns come as a big surprise. Finally, I will briefly touch upon yet another significant feature in RFM, a unique potential cost overrun predicting feature which is only made possible because RFM is both based on risk analysis and computes cost at completion. Computing cost at completion means that any influence today's events or activities may have on future events or activities may also be taken into consideration. In the example, see the figure, the activities have been distributed along a time scale, a Gantt chart. The three future dependent activities green have been set up to correlate with the independent activity red in such a way that a cost increase in the independent activity will trigger possible cost increases in the three future activities. For example, a cost overrun in engineering work today is likely to trigger cost overrun in future engineering work and possibly also future construction work. Hence, potential cost overruns may be revealed weeks or months earlier than in traditional cost control systems, long before the increase materialize. This is real forecasting. Now let's see how these dependencies influence on the total predicted cost at completion. In RFM, any activity may influence on one or more future activities. They are said to correlate. The magnitude and direction of the correlation is determined by a correlation factor. In RFM, the correlation factor is normally denoted small r and may vary between -1 and +1. If the correlation is set to 0 between the activities, the resultant frequency curve will become bell-shaped, providing the number of activities is large. So this is it. R is equal to 0. N is large number of activities, and the result is a bell-shaped curve. If, however, the green future activity correlates with the present-day red activity in such a way that if the red experiences a cost increase, the green future activity may also increase in cost. The correlation is said to be positive, more than 0. The risk of future cost overruns is then imminent. Now, what happens then is that this resultant curve no longer becomes bell-shaped, but it moves to the right like this. I'll go back. The most likely point moves from 6.4 to 7, and the resultant frequency curve becomes no longer bell-shaped but is skewed towards a higher value. So the P50 is actually over here. Now we go back. R equals 0, n is large, R equals a number larger than 0 but smaller than 1, and it's no longer bell-shaped, and the most likely cost has moved to the right to a higher value. As I've already mentioned, RFM predicts potential cost overruns weeks or months earlier than single point forecasting techniques normally do, because RFM better reflects what is happening in real life than simple single point forecasting techniques will ever manage. I'd like at this point to present the report screen, which you've seen as a small icon on the top right hand corner of these presentations. And the reason why I'd like to show it now is that I can then point out exactly what these different things are. This is the result of all the calculations, and in the RFM screen report it will look like this. So this curve is the same as this, but in addition you have accumulated the frequency curve, and the distance from here to here within 1090 and 9010 is the same as the distance you see from here to here for the last report period. These are exactly the same numbers, and the same numbers are also shown up here and in the summary lines in this detail report. All the numbers here in red predicts cost above budget, and green is equal to or below budget. Black is normally the budget itself, like here and here. If you wish to learn more about RFM, please visit rfm3w.com. Thank you for watching.